Welcome, everybody. My name is Lucy Norval, and I'm the coordinator of programming and communications for the Scarborough Public Library. We have a really robust audience tonight for our night sky tour for families. So I wanted to also say hello. There are several of my colleagues, several librarians on the call tonight. And we've got our youth services manager, Louise Capizzo. We have Catherine Morrison, who's the adult services manager. We have Denise Menard, our cataloger. Tom Corbett, our systems librarian, is doing all the behind the scenes work for us. And we also have Nancy Kroll, the library director, on the call. So lots of people from our team are here tonight. So without further ado, I want to introduce you to Seth. And as a kid in down east Maine, Seth developed an early fascination for the night sky. Guided by his father's love of astronomy, he quickly learned how to use a telescope and different kinds of star charts. And from there, Seth gravitated toward the amazing stories of space exploration, not just stories of crewed and robotic missions, but also stories of diligent researchers and how their scientific discoveries changed our understanding of the universe. Seth graduated from the Maine School of Science and Mathematics in 2011, and in 2015, he graduated summa cum laude from the University of Maine with a bachelor's degree in psychology with a focus on statistics and research. So shortly after graduating college, Seth created a weekly half-hour talk show about the night sky and the universe. And during its 4-year run, the panel interviewed some amazing guests, did live shows and presentations at STEM events across the state. STEM stands for Science, Technology, Engineering, and Math, and became the first radio program to join the NASA Museum Alliance. So after interviewing the CEO of an aerospace startup in Brunswick, Seth left the show to work for the rocket company. And the radio show continues under a new name helmed by the remaining panelists. Currently, Seth manages communications for the aerospace startup. The company's developing a new type of rocket to launch tiny satellites, a little bigger than Rubik's cubes, on suborbital flights and to low Earth orbit. He also advocates for the ongoing effort to build a spaceport here in Maine. Seth also volunteers as a solar system ambassador with NASA's Jet Propulsion Laboratory, communicating the science and excitement of NASA's space exploration missions and discoveries with people across the entire state of Maine. So without further ado, here's our solar system ambassador for NASA, Seth Lockman. Thanks for being here tonight, Seth.
Thank you for having me. This is a pleasure and an honor. And wow, there's a lot of like high profile people here now. I'm a little nervous, but I'm looking forward to it. So I'll try and get to all of the questions in the chat. If it's all right, well, let's see. How quickly can we get through these? Okay, what is a wormhole? Wormhole is well, there's a couple different ways, but basically it's a theorized bridge in space-time between a black hole and a white hole. And the idea is that rather than moving through space, because there are limitations there, you essentially move space around you. It's like it's like the difference between walking and then walking on one of those weird treadmill escalator things at the airport. But the thing is, to make the universe move like one of those treadmill escalator things, you need a whole bunch of exotic matter, negative energy, there's all kinds of problems with it. But according to Einstein's predictions, it should be possible to achieve. What is the next probe NASA will launch? Sorry, I don't know. It's basically like daily, and at this point, as satellites get smaller, they're just launching, tens of them at a time. Is a good place in Portland metro area to look for the northern lights? No, you have to be farther north for the most part. It's pretty rare that northern lights come down this far south. Do white holes exist? Theoretically, but we've yet to observe one. And any other planets beyond the solar system? Yes, there are thousands. There are 2 missions that I would recommend you look up, and they do have some kid-friendly materials. The first one is the Kepler mission. That's Kepler, and that what is a well? Oh, okay, sorry, I'll get to that in a moment. I do consider it a personal failure if I get all the way through a presentation. So this is just amazing. So after Kepler, there's also a TESS, and that's TESS. And if you look up, TESS NASA, you'll get it. It's the Transiting Exoplanet Sky Survey, and these two missions have shown us that but before this, like 15 years ago, we thought there could be a lot of planets out there, and now we know that there is a ridiculous number of planets out there. That it's the exception to find a star that doesn't have planets around it. So anyway, that's where to go looking for more information. What is a white hole? It's the theoretical opposite of a black hole. And instead of basically absorbing everything that gets too close, it just puts out ridiculous amounts of energy and matter, usually in the form of subatomic particles, really, really energetic stuff. And the theory is that a white hole is getting all of that stuff from whatever fell into some other black hole. And so that's one way you could have a wormhole. Wow. Okay. Thanks so much, guys. I may lose track of the chat, so Lucy will jump in as questions are asked. So, hi. Who's this crazy guy talking about, dog stars and black holes and white holes? I am Seth. Thank you so much, Lucy, for the lovely introduction. And this is our star tour. So the goal of tonight is I'm going to go over some of what you can see in the night sky with the unaided eye. And then after this, or hey, maybe you're, near the porch as you watch this. I don't know, you can look out. But the idea is you can just stop the program, walk outside, look up and see what we were talking about tonight. I'm ready to go. I've got my laser pointer. I won't even use it. It's just habit at this point. So one thing that I wanted to mention is modern professional astronomy overlaps very little with what we're about to discuss. What we're doing is largely historical. Modern astronomy is basically like computer programming and statistics. Many professional astronomers have never handled a telescope. They simply don't need to, and technicians thousands of miles away execute the computer programs they write, send that data back to them for analysis. And so looking through a telescope is really just about like having fun and having a good time. Although now that we're getting better at knowing what to look for, if you want to like discover something new with a telescope, comets are the growing thing. There's a growing rate of amateur detections of new comets. In fact, the most recent interstellar object was discovered by a private citizen in, I believe, the Ukraine. So it's and it's also not just telescopes. Some people will pour through astronomical data with their own algorithms and discover new comets that way. So anyway, there are tons of things that you can do to advance science still, like at the hobby level, and it's improving again. But mostly, this is just about having fun and kind of like dialing in the cosmic perspective. So, to that end, as you may know, astronomy has not always been a distinct field. In the ancient world, it was inseparable from spirituality and religion, and it was critical to agriculture, and it was considered a kind of a sub-discipline of philosophy in ancient Greece. It was a philosopher who, as the story goes, predicted the first solar eclipse. And of course, until GPS, if you owned a boat, if you were a sailor, astronomy was just another word for navigation. To the point that on Apollo, astronauts were trained to use constellations to navigate if the guidance computer failed. So with that in mind, here's my question. Here's my question for you. What time do you think it is in this picture? And I guess we can't all chime in, so I'll give it a couple seconds. Make your guess. What time is it in the picture? And okay, so it's a long exposure shot, right? It's nighttime. Here, right? I mean, you can see it's dark, you know, there are lights on, the cars have their lights on, the buildings have their lights on. So you would say it's night, right? 8 p.m. Yeah, okay. These are all good guesses. 8, 9, yeah. So what if I told you that it's day in this picture? What would you say? You'd say, oh, he's crazy. I've given an hour of my Friday to a crazy person. This is great, just great. Okay, so here's my point. Sure, it's night here. Can you see my mouse and everything? But how about here? Because on the moon is reflecting sunlight, right? So that means that sunlight is hitting the moon directly. So if you were standing on the moon, to you it would be day. In fact, along this line right here, this line of longitude, it would be noon while it's the middle of the night over here. And so the point of this exercise is to get people thinking about how our common experience of the world, it starts to kind of break down a little when you hit the cosmic perspective, when time becomes a place and your definitions start to shift like that. It's those kinds of things really will start to happen if you wind up engaging in astronomy, and it's a lot of fun. Okay, so before I show you what you'll see in the night sky tonight, I want to just go into a couple of different ways to look at it, ways to examine the celestial spheres. So the first one, and this is perhaps the most obvious, is to look up at night. That second part's important. Now, you can see an amazing amount of detail in the night sky unaided. However, especially in Maine. However, you might want to use some sort of an aid, right? And so there are all kinds of magnifiers, telescopes, basically. You've got your spyglass, binoculars, and binoculars are actually really, really good. A lot of people are ready to throw down a large amount of money on a telescope, and maybe they should consider binoculars, especially for the portability. And then you get into telescopes, and of course, as they get bigger, you know, your price point goes up a little bit, and then you know, eventually you get to the kind of orbital thing, and those cost probably the most. So for most people, a backyard telescope is about as big as you need to go. And it's not just a telescope. You're not just kind of, you know, getting pushed out of the nest. There's all kinds of ways to kind of get some idea of what you're going to see while you're still looking down. So one of the best ones is a planisphere. That's not actually how you spell it. I think this is from the Netherlands. Yeah. So, oh, down at the bottom. Yeah. Go away. Okay, well, it says planisphere down there, and eventually this will go away and you'll see how to spell it. This is kind of like the last remaining slide rule, and it has a graphical interface. So you buy one for whatever latitude you're at. We're at about 43 degrees north. So if you get like a 40 degrees north planisphere, that'll be about right. There's the North Pole. You dial in the time and the date, and then this will be your star field. Wherever this North Star is, you'll have to kind of hold it overhead a little bit, but you can align to your north, and there's a couple tricks. You don't necessarily need a compass. I'll show you how to do that. But planisphere is terrific. You can even get glow-in-the-dark planispheres if you don't have a flashlight. So, celestial globe. Often this is more heavy and ungainly than a telescope, so I would not recommend it for your stargazing pursuits. However, looks really good on a desk. One of the more confusing things about a star globe is now all of a sudden you're looking at the outside in on the night sky, right? And from Earth, we're usually kind of looking out. at this imaginary celestial sphere. So when you're looking in the other direction, everything is inverted is probably the best word. But you can still get a good sense of where the constellations are in relation to each other with this. And of course, the star atlas. If anybody's familiar with the Maine Gazetteer, it's basically like that. You turn to a certain page and you'll get your constellations. And a constellation is a whole region of space. And then you can see the asterisms, which are like Gemini, Pisces, Orion. Those are asterisms. But and then you can see, reference materials. So, if you're curious, like, oh, hey, this star here, what's it called? How many planets does it have? And then down on the bottom of the page, it'll have that information. So star atlases are terrific, and they make them, for all different levels. And then of course there's simulations. So there are tons of good free smartphone apps that you can download, and some will even move with your phone's accelerometer. And so you can point your phone and it'll give you a pretty close approximation of what you'd be looking at if you just dropped your phone away. So those are good. Desktop programs like the one that I'm about to show you this evening, it was free. And so there are plenty like that can be super helpful and help you zoom in on stars and planets. Email alerts, NASA is really, really good about this. If you want to know when the next space station flyover is or something like that, you can sign up for that kind of an alert at NASA. And a planetarium near you. Now, near you guys, I think it's going to be the Southworth Planetarium at USM. That's going to be the closest, and they're closed for COVID. But when they're able to reopen safely, excellent simulation of the night sky. And last but not least, of course, what we're doing now. A couple more pointers. So please, please, please use red light. Now, why should we use red light? This is what we call a dark adaptation curve. Won't get too much into it, but as your eyes, spaceweather.com is great too. Agreed. So as your eyes adapt to the dark, it takes time. There's actually a different set of sensors in your eyes that they don't get color very well, but they get that kind of light black, they pick up contrast really well. And so you switch over to that part of your eye to see in the dark. And that whole process, it trails off here. Oh, this isn't a function of, well, okay, so if you're in pitch black, basically your sensitivity to light increases. So this is the amount of a stimulus needed to see like a flash, and it just goes down. So here it goes to 50 minutes. But actually it's closer to like 2 hours to fully adapt to the dark. Now, why is this? I'll give you an example of tonight. Sunset began 4:04 p.m. and astronomical twilight ended. So true night began at 5:48 p.m. So it was about just under 2 hours to go from light to dark. And so that is the environment that we evolved in. And so why would our eyes ever need to adjust faster than that, right? I mean, people have only been turning out lights for what, maybe 100 years tops. And so usually sunset was how we would adjust to the dark. Red light is the least energetic type of light. So if you must use a light, red light is going to damage your night vision the least. Now, using a white light isn't, unless it's incredibly powerful, it's not like hurting your vision, it's hurting your dark adaptation. And so when you turn off a white light, if you need to see in the dark, you're starting a counter, a 2-hour timer from 0 again. And with red light, I don't know how much less time it takes, but it's like significantly less. So if you're stargazing and you have a red flashlight, it's going to allow you to see more and get to that point faster if you have to turn on the light and then turn it off again. If you only have a white light, you can use red tape or cellophane, or age of smartphones, there's an app for it. A couple other things. The library has some really excellent resources, including a telescope, an Orion Star Blast. It's a reflector, and maybe this is the most important stat about the telescope. It weighs less than 4 pounds, so it's highly portable, and I'm sure very convenient. If you're thinking about getting a telescope, I cannot recommend strongly enough trying one for free first. And there's two main reasons. First of all, if you get a telescope, one of two things is going to happen. Either you're going to try it for about a week and then get bored and just put it away somewhere and move on with your life. Now, thanks to your local library, you can go through that process for free. Save a couple $100. That's really awesome. Second of all, let's say that you go down the rabbit hole and get really, really excited by astronomy, which is what I hope will happen. Getting that first telescope, that's free money later that you have to invest in a better telescope to get a better stargazing experience. So by the time that you go into to start shopping, you already know what you liked, what you didn't like, what you might want a little bit different in a telescope. And just having that level of exposure, just 90 minutes of stargazing will give you a really, really good sense of what you might like. Because with a telescope that small, you're not going to see the greatest detail that you possibly could, but maybe that portability is really important to you. Or who knows, maybe you want to look at surface features on the moon. That's a very different telescope than what you would use to look at, other galaxies, right? Okay. Other resources that the library has, they've got a web page, Sky Gazing Resources at Scarborough Public Library. You may have seen it on the event page. There's a monthly evening sky map, which is also like the planisphere. It's set for 40 degrees north. I didn't check what time of night it's specifically for, but usually those things are for the late evening as you go out. And it does assume that you're going to be looking south, just so that north is up on the paper. So if you're looking to the north, where a lot of the really good winter constellations are, you just hold the paper upside down, you'll be fine. And then also the bane of any astronomer's existence, the weather, right? And so the library has a link to what they call a clear sky chart, and you can see what the cloud cover is going to be like on a given night. Okay, so what to look out for tonight. I did a little bit of checking for you. I realize now that I didn't check on the weather. My apologies. Satellite or space station flyovers, nothing, sorry. Meteor showers, we're in luck. December 13th to 14th is the peak of the Geminid meteor shower. So it'll be coming out of the constellation of Gemini. I'll show you how to find it. It's one of two annual meteor showers that is not caused by a comet. It's caused by an asteroid. That means that the grains that are kind of trailing behind this asteroid are metallic. They're much, much denser than what you're going to get in the trail of a comet. And so as the Earth flies through this debris tail, it's going to be probably fewer kind of explodey ones. Sometimes you'll see a shooting star that explodes at the end. So it's going to be less of that, and it's going to be more of these smaller fragments. So it should be up to 100 meteors per hour. So that's one every 36 seconds coming from the direction of the constellation of Gemini. And then later on December 22nd, we're going to have the peak of the Ursids. And so that's going to be coming out of Ursa Minor or the Big Dipper. And that's one of the first constellations I'll show you how to find. Some cool planet stuff that's going on out in the night sky. Mars got really close to Earth in October, and it still is pretty close. And so a lot of Mars is just particularly bright right now. Sorry, that's my bird clock. Are we done? Okay, good. So Mars is particularly bright. It's in the constellation of Pisces. And then also, and a bunch of people have been talking about this, Jupiter and Saturn are in this very beautiful visual conjunction, the closest that they've ever appeared to be in the night sky in about 800 years. And I checked the last time that they were actually one right on top of the other, which we call an occultation. That was 8,000 years ago. So that is incredibly rare, but getting as close as they will, which is about 1/10 of a degree or 1/5 of the apparent diameter of the moon. So really, really close. They'll be getting on the solstice on December 21st, and hasn't been that close in 800 years. Oh yeah. Okay. The moment you have all been waiting for, the star tour. Let's see how we can do this transition. Boom, there we go. So here you are, Scarborough, Maine, and you go out into your backyard. So we're facing north. How can you tell if you're facing north? Well, you can have a compass, you can have a phone app or something. You might just happen to know how your house is situated. So you know, oh, if I walk out this door, I'm facing some direction, and then I turn left. I don't know. Name of the program is Stellarium. Yeah, Stellarium. And so this is about, 8:40 tonight. So let's wind it back just a little bit. Those prone to motion sickness. Should have warned you earlier. Okay, so when you're facing north, one of the most easy things to recognize is going to be this right here. Can anyone tell me what that is? Yes, Big Dipper. You get science points. Okay, so the Big Dipper is one of the most easily visible constellations in the night sky, and it's circumpolar, which means that from our latitude at least, it never really sets. It's just always going around in a complete circle in the night sky, and sometimes the sun is up so you can't see it, but it's always up in the sky somewhere. Now, this early into the evening, you can see the last star in the handle is just underneath the horizon, but basically we call it circumpolar. Now, the Big Dipper is not just easy to see, but it's super useful for kind of moving around the night sky. So if you take these two forward stars in the cup of the Dipper, and that's, let's see, Merak and Dubhe, I believe. Yeah, nailed it. So Merak and Dubhe, and you draw a straight line, you're going to go about 25 degrees in the night sky, okay? Let me zoom out so you can still see the ground a little bit. There we go. Okay, so you're going to go about 25 degrees up. And in the night sky, if you take your pinky and your thumb and you make like you're picking up a telephone. I don't know if you guys can see my my camera right now, but if you make that telephone symbol and then hold it out at arm's length, that's going to cover about 25 degrees of the night sky. So you can draw that line, and there'll be about one hand telephone away, drawing that straight line off of Merak and Dubai up to Polaris. Polaris is the North Star. It's within 1 degree of the celestial North Pole. And so this star right here is how ships would navigate at night for thousands and thousands of years. You can see the Little Dipper here. So its handle curves in the opposite way of the Big Dipper. And then it's got this little cup here. Now, Polaris is not the brightest star in the night sky. It is the 49th brightest star in the night sky. What's unique about it is just that all these other stars are going to be moving in a circle around it, and Polaris will not appear to move very much at all. And it'll basically always be due north, at least for the next couple thousand years. Now, we're going to move just a little bit to the west here. And so here we have the Big Dipper and the Little Dipper. And does anybody else know the other names for the Big Dipper and the Little Dipper? Yeah, it's the Ursas, exactly. So these are bears. And let me see if I can bring these up here. Yeah, there we go. That looks more like a fox than a bear, if you ask me. But yeah, so the Greeks imagined that this was a big mama bear and that was her cub. And so you can see the asterisms within the larger constellations. Now, between the two bears, you may have seen a dragon. So again, Big Dipper, Little Dipper, and like right between the two of them, you've got the tail of the dragon, and it curves up around here and then goes down there. So for any Harry Potter fans, this is where Harry's kind of arch rival got his name, right? This is Draco right here. And there's other cool animals up here too, because if you take the Little Dipper and kind of the top of Draco and you go kind of a straight-ish line, you're going to hit Cygnus the Swan. And so Deneb is the tail star of Cygnus. It's really bright, really beautiful. And so it looks kind of like a cross here in the night sky. Now, coming back, because everything always comes back to the Big Dipper. I had this one teacher that, just to mess with us, he related everything to the star Spica. Just use the Big Dipper as my personal opinion. So we're going to take these two stars up top here. So this is Dubhe again, and then this one is Megrez. Okay, yeah. And we're going to draw a straight line off of these two. And it's going to land you kind of in the neighborhood of this little pentagon here. See that? It's like a home plate. So that's Auriga, the charioteer. This is one of the constellations that we aren't entirely sure of the story. Historians piecing things together thought that this was a spurned Greek prince who became a charioteer, and then also in his spare time was a goat herd. And so up here this is Capella, the goat star, and it's another particularly bright star that in the original Planet of the Apes, before they realize they've traveled through time, because the sun is a little bit bigger at that point, they think, hey, maybe we landed on Capella. So anyway, there are a couple of stories that imagined Capella as being, home to an alien civilization. We now know that there are 9 stars orbiting in that system. So even if it does have any planets, I would not want to live in a system with 9 stars. So now the next thing is pretty easy because we're not drawing any lines with stars. From Auriga, from Capella here, we're just going to go straight down. Boom. Here are 2 stars. You can kind of draw some stick figures here. Yeah. This guy might need a chiropractor. I don't know. But these 2 guys have kind of got their arms around each other. So that is Gemini. So that's Castor and Pollux. And this is about where that really, really good meteor shower is going to be if you go out tonight or for the next couple of nights. There we go. There's the Geminids. So if you look to the east, you should see, because this is the direction that the Earth is headed, and also kind of the direction where that tail of debris is, it'll feel kind of like in Star Wars when the stars go flying by. It'll be kind of like that. Like if you watch enough meteors, excuse me, it'll seem like they all kind of are coming in the direction of Gemini. Now, when we get to Gemini, something interesting happens because we're about to get to one of the most iconic constellations and one of the most controversial stars in the whole night sky. Because going off of their feet and going down just a little bit, does that look familiar? Well, yeah, that is Orion. He got a belt, but he didn't like it, so he gave it only 3 stars. So there's his belt. There's his sword. The Orion Nebula is one of the most beautiful night sky objects. It just, with the false color images from NASA, is terrific, but also through a telescope, it looks really good. And then down here, you've got this white blue star Rigel, very bright. And then up here is Capella. Now, oh, wait, what am I saying? Capella. Betelgeuse, of course. So Betelgeuse is an absolutely insane star. We do not have enough time tonight to go into how insane this star is. Real quickly, I'll mention that we think that it swallowed another star at some point. And also, last year around Thanksgiving, it started to get dimmer and dimmer until it got to about 40% of its normal brightness. Now, that's sort of a change in the night sky. It's really weird, right? So a lot of people thought, hey, is Betelgeuse about to explode? I mean, we know it's a red giant, right? It's an older star. Is this it? And it turned out that it was a giant gas cloud. So our own star will do this sometimes, where it'll fling off a large amount of gas. But with Betelgeuse, the surface gravity is so low that it can fling off just a ridiculous amount of gas. And as that gas cools down, it starts to block out the light of this star. And so this star basically created its own nebula between us and it. And so that gas blocked out the star until it was able to kind of spread out a little bit. And so the star dimmed to less than half of its normal brightness. And it got back almost up to its full normal brightness. And then recently it started to get dim again. So is this just a weird year or two for Betelgeuse, that it's just throwing off a little bit more dust than usual, or does this mean something? Well, we don't know yet, but probably it's not going to explode for tens of millions of years. What star phase is the sun in? The sun is what we call a main sequence star. For its stellar class, it's going to live about 10 billion years, and we're about 5 billion years into that. So it's a middle-aged star, and it should be incredibly stable for at least like the next 2 billion years or so. So we've got plenty of time to figure out the whole warp drive thing. And at no point will the sun ever be quite as big as Betelgeuse. Betelgeuse was just a huge, huge star to start with. But yeah, just an absolutely, if stars were people, Betelgeuse would be like the crazy uncle. It's always up to some sort of mischief. And so if you're interested in stars, just take a look at Betelgeuse. Now, Orion is joined by his two hunting dogs. And so over here, you have Canis Minor, a very simple constellation, just one line right there. And then over here, you can see it just came up. So it's about 8:14 at night here. You'll finally be able to see Sirius, unless there's a house or a tree there. But this is the brightest star in Canis Major, the larger of Orion's hunting companions. Yeah, absolutely. So there's Canis Minor, Canis Major. He's Orion. Sometimes he's shown holding a lion's hide. Sometimes this is just a shield. It depends. So if it's all right, maybe what I can do is bring the drawings up every once in a while. But I really want to show folks what, the closest thing possible to what the night sky is going to look like. So hopefully that'll be all right. But if you go back here to Orion and you go essentially straight up, you're going to see this really bright star, and you can kind of make out this V here, and you can even draw the V out like that. See? And would anyone care to hazard a guess as to what this is here? No. Good guess. All right, I'll tell you. So this is Taurus, the bull. And that star is Aldebaran, that's his eye. There's Taurus, the bull. Now, in the region of Taurus, so in the constellation, but not part of the same asterism, there's something really, really interesting. I'll even zoom in on it for you. Oh, I gave it away. It's the Pleiades. This is the Pleiades. This is the Seven Sisters. So, here's a fun question. Does anybody know the name for the Pleiades in Japanese? I'll give it a second. I'll give you a clue. Does this look like a logo that you might see on the front of a car? Like a station wagon kind of thing? You know, made with love. Yes! This star cluster is called Subaru in Japanese. And I apologize, I probably butchered the pronunciation. So there's a story that we can tell with this patch of sky. Because you see, the Seven Sisters there, Orion is interested in them. Maybe he wants their phone number or something. But they're not really interested, so they're trying to get away. They're trying to make some distance, you know. And their buddy Taurus here is kind of blocking Orion, but he's very persistent. And so if you play the night sky, so we're going to speed the night sky up here. And you can see Orion chasing the Pleiades across the sky with Taurus continuing to run interference. And so in that way, the ancient Greeks were able to make kind of like a movie. There's a story here, not just to the shapes in the sky, but also to their motion relative to each other. And of course, Orion is being followed by his barking dogs, who just kind of, you know, they're dogs that just want to be a part of the thing. All right, so let's get back, because this is about like 11, so no one's staying up that late, right? No, you're not staying up that late. Okay, so here we are. It's 8:15 again. And so I told you how we were going to find Mars in Pisces, right? Well, it turns out that Pisces is an incredibly difficult constellation to find. Just murder. I would not recommend it. So here's what you do to find Mars. You're going to take Orion. Now, it was shown as being a lion's hide, but we're going to pretend this is like a bow or something, right? So here's his arm drawing the bow, which I guess then there's the question of like, well, what's the club doing up here? But don't worry about that. We're going to shoot an arrow with our minds, and it's going to fly mostly straight. And up, and there's Mars. Excuse me. And so Pisces is kind of there. It's hard to see though. Okay, so here you can see it a little bit better. But that's where Mars is, and it's very bright right now. So I would highly recommend checking that out. What are the historical records and sources that tell us what the ancient Greeks called the stars and what they saw as constellations? Well, for the ancient Greeks, we actually don't have too many star names. Most of the names of our stars are Arabic, but the constellations are, or at least most of the most prominent ones are Greek. What sources do we have? Off the top of my head, I can't give a good example, but I do know that many philosophers published star catalogs, including Plato, who, and they also plagiarized each other, because they didn't really have academic integrity laws or policies like we do today. So they would do that thing. I don't know if you've ever seen anybody do this, where they say, oh, I'm such a great fan of this other philosopher, and I read their work and I thought it was really good. And then you find, later on in their work, that there are some star charts that like clearly the date is wrong and they just copied this other guy's work. And anyway, that's kind of funny to see in the ancient world. But yeah, so we've got constellations, not so much star names. Are there any planets that are parts of the constellations? No. And the reason for that is that the planets move. In fact, the original meaning of planet was just that it's something that does not move like everything else. There were wandering stars. So all of these other stars. Now, on deep time, over hundreds of millions of years, if you look at how the stars move in our galaxy, it's like a demolition derby. I mean, it's insane. They're all going in different directions and they're all swinging around each other because of gravity. But over a human lifespan, 70, 80 years maybe, the stars really do not appear to move. The constellations, give or take 1,000 years, the night sky looks pretty much the same, right? Except for comets and the planets, Mercury, Venus, Mars, Jupiter, and Saturn were the ones that were visible to the ancients. And interestingly enough, the moon and the sun were also classified as planets originally, just because they didn't move like all of these other points of light. And so the planets move through the constellations. And that's where you get like the concept of the zodiac, where what constellation is the sun in? That is all based off of this old idea that the sun is a planet, just because it moves differently. Excuse me. And so maybe, I don't know if I should mention, this might be kind of a hot button issue still, but when we talk about whether or not Pluto is a planet, part of the debate that I wish people would acknowledge is that the entire definition of a planet is flawed. It's a chewing gum and duct tape kind of patchwork repair job on this definition that is not really the best for understanding our universe. But anyway, that's Mars. It's in Pisces and it's beautiful right now.
Seth?
Yes.
I wanted to take a moment to encourage people to put questions into the webinar chat box. I think that there are a couple of people who have raised their hands, which may mean that they have questions.
If somebody wants to ask, please.
So you're doing a really nice job of keeping track of all the questions as they're coming in and weaving the answers in as you go. So I just wanted to encourage people to ask questions in the chat if you can.
Thanks. Yeah. One other thing I said I would point out is the Ursids. So they're in Ursa Minor, right? So again, you come back to the north, you find the Big Dipper, you draw that line, Little Dipper. The Ursids are going to be coming from right about there. So they're within the constellation, but just outside the asterism of Ursa Minor or the Little Dipper. And so that, let's see. I'm going to cheat and check. Sorry, magic behind the curtain. So one of them is going on right now. One of them is mid-December. Which is it, Geminids or Ursids? I bet you guys will figure it out faster than I can. Never ever prepare for a presentation, or otherwise the knowledge all goes in one ear and out the other. Okay, Geminids are right now, and then in a couple weeks, the Ursids. So you'll probably see one or two, coming out of this region of space right now. But really, December 22nd is when you're going to want to be there. But mostly it's going to be Geminids right now. All right. Okay, Team Pluto is a planet. Love it. Love it. What makes a star and a planet a planet? Well, under our current definitions, a star is anything which has stellar fusion going on in its core. So basically, hydrogen atoms are slamming together with so much energy that their nuclei fuse and become a heavier element, in that case, helium. And they continue down that process. I forget every element in that process, but once they start fusing iron, then the star's in trouble because it's not producing enough energy to counteract its own gravity. And that's when you get all kinds of interesting explosions. But a star has nuclear fusion and to some extent fission going on within its core. And then a planet is something that does not do that. And there are problems there. There's evidence that Earth's core might have, well, probably not fusion, but fission probably, so that there's energy being released from Earth's core due to nuclear activity. Is that are we a star, or do we just have geothermal energy? I don't know. Or there's the idea that like a planet never produces its own light. Well, planets have lightning, planets have aurora. I guess you could argue that both of those phenomena are ultimately caused by the parent star, but so the definitions, they don't work quite as well when we leave our solar system as well. So, for example, the first ever exoplanet that was discovered was orbiting a pair of burned out neutron stars. So they don't have any nuclear activity going on in them. So is it really an exoplanet? Because is it really orbiting another star? You just start to run into like issues with the definitions like that. But yeah, basically a star fuses atoms in its core. A planet does not. Usually the planet goes around the star. It probably almost certainly would not go in the other direction with a star orbiting a planet. What is the closest star to Earth other than the sun? That would be Proxima Centauri, which is one of 3 stars in the Alpha Centaurus system. It's not visible in the northern hemisphere, it's in the southern hemisphere. And there's a planet around it that we thought might be pretty Earth-like for a while. And there's some new evidence that shows it might not be quite so habitable. But yes, there's a star. It's just over, I think it's like 4.26 light years away is the Alpha Centauri system, and then Proxima is the closest. But it won't be the closest. In a couple thousand years, there's another star that's going to get much closer. There will be a time when in the sky there will be no stars and the universe is expanding. Yeah, so what we do know is that space is expanding at all points. And you have these what they call gravitationally bound systems. So we're in the Virgo cluster of galaxies. And there will come a time where we can't see any other galaxy cluster. But there's some debate as to, it's generally accepted that we'll be able to see a couple other galaxies nearby, certainly stars within our own galaxy. That the kind of the force of gravity will just kind of hold stuff together more than space-time can expand and then push everything apart on small scales. But on large scales, we may eventually even get to a point where you just can't see any other galaxies. That will be so far into the future that our sun will be long gone by that point. When are we going to land the ISS? Well, it can't land. That would be, as they say in the FAA, if you walk away, you landed okay. But that would be a really rough landing with the space station. There's been talk of kind of pushing it out of orbit. It's at the point now where some of the modules are in excess of 20 years old. One of them was leaking. I'm not sure. Oh yeah, thanks. I'm not sure what their current status is on that. It's nothing critical, but you want your space station to leak as little as possible. Currently, the plan, I believe, is to commercialize the space station and hand over control from NASA, or probably NASA is going to still some. I shouldn't speculate. I really don't know exactly how they're going to administrate the station, but the plan is to start bringing in private money and if a company wants to run an experiment on the station, basically some of that money goes to maintenance of the station. So with a little bit of luck, it'll keep going for decades. With the modularity of the space station, if one part of it fails, in theory, you just pop the station apart, replace the broken module, and then slip everything back together like Legos, right? So eventually you get into kind of a ship of Theseus slight kind of issue, but yeah, we could have a long time left of the station. When it does deorbit, if it ever does. I'm sure that they would aim for somewhere in the Pacific Ocean, kind of like what they did with Mir, the Russian space station, just to reduce the chance of it hitting anything. Although when we deorbited Skylab, the first ever American space station, a piece landed in Australia, and the story goes that we went to go get it because it was, you know, it was the biggest piece of our first ever space station, and Australia said, okay, you can have it, but we're going to fine you like $400 for littering. And it's my understanding that the United States paid the fine and then took the piece back to the Smithsonian. All right, well, I guess we're at the end of the questions. Any other questions about the night sky, or is everyone just kind of eager to get out there and see what they can see? Do I have a favorite star? Oh, well, man. I mean, would it, how many stars are there? Well, we don't really know. In our galaxy, somewhere between 200 and 400 million. In the universe, we don't really know where the universe stops. What's my favorite star? I'm going to go outside of our sun, which is remarkably stable, and I really, really appreciate that. Proxima Centauri is pretty cool. It's close by, and regardless of how habitable that planet is in orbit around it, I'd love to see a mission there. What's the, okay, spaceweather.com. I have never paid for premium anything with regards to stargazing. So I can't tell you if it's worth the subscription cost because I just don't know. But I have gone to that website before. What's the impact of satellites like Starlink for amateur stargazers? That's a good question. Reports of it kind of varies to like how annoying it is. I think that astrophotographers, you know, people that are trying to get these long exposure images of like deep sky objects are being more affected than people just looking up. Most of the casual stargazers I know, that, you know, they'll go out for like half an hour in the late evening to kind of see what's what. They love seeing satellites and stuff like that. It's not until you get into the kind of the heavier hobbyists and certainly the professionals where you get a great deal of upset about the Starlink constellation. And a while back, there was the Humanity star, like that giant disco ball that they launched into low Earth orbit. So yeah, light pollution is it's definitely an issue that we're going to have to deal with some regulation and well, yeah. Okay, how big is the sun? Off the top of my head, I couldn't tell you. And you could probably Google it faster than I could. I do know that the sun contains like 99% of all the matter in the solar system. So it's just ridiculously huge, ridiculously massive. What is a neutron star? Oh, that's a good one. So when a star dies, say you have a star the size of our sun, right? So when the sun dies, it's going to grow into a red giant and then it's going to just kind of slough off the outer layers. It's going to create this planetary nebula that, assuming we survive and are able to observe from a safe distance, will be absolutely beautiful. And the result will be a white dwarf star. White dwarfs are just these tiny stars that they're incredibly stable and small, and they don't put out a lot of energy, and they'll probably be the last thing shining at the end of the universe. Like we're really not sure like how long they can go, but we know it's a really long time because as they cool down, they go through all the other dwarf star stages. So so that's what happens when something like the sun dies. Now, a little bit bigger than that, but not quite big enough for the core to collapse into a black hole. You've got a neutron star. And so what a neutron star is it's the remnant of a stellar core, and it's surrounded by a supernova remnant. And the core collapses so hard that all of the protons and electrons just get squeezed out. And so it's not like normal mechanical pressure that we can exert by, gripping something or crushing a car or something like that. That's all happening at the, I guess you could call it the chemical level. Bonds between molecules, bonds in molecules, like between atoms, are being altered, but the atoms themselves are not affected at all. And so it's an entirely different energy regime where the protons themselves get violently ejected and squeezed out of the atoms. And so all that's left is this incredibly dense ball of neutrons. And because a neutron is actually a proton and an electron combined, and therefore of neutral charge, but there still is charge in there, just the net charge is zero. Anyway, somehow it's able to have a tremendous magnetic field. And so a neutron star will tend to spin really, really fast and have jets coming out of the poles, kind of like a black hole does. And so if that neutron star is tipping end over end in such a way that Earth gets to see that jet, that's when you have a pulsar. And it's basically the most precise way to keep time in the universe. Any pulsar with a known period, it doesn't vary at all. So anyway, I hope that answers the question about neutron stars. Are there good places in Maine with minimal light pollution for stargazing? Yeah, Maine is really, really lucky that we have incredibly dark skies. Outside of Portland, Bangor, Lewiston, Auburn, oftentimes all you have to do is really just kind of go outside. It was kind of funny, I've been to the Acadia Night Sky Festival a couple of times, and up on top of Cadillac Mountain, it was beautiful, but you had like light pollution coming up from the entire island. And so when we went back to the campsite, which is on the west side of the island, then I could see the night sky with the clarity that I don't remember ever seeing before in my life. So for unaided eye stargazing, just anywhere that's dark enough will do fine. If you want a place with telescopes to do stargazing, then you have to start thinking about how level is the ground, how close is the nearest road, so how far am I tugging my telescope into the woods, or you might. There are a couple of observatories across the state. There's one in Kennebunk. They're working on one in Limestone right now, and there's one in Orono. So if you want to use a really good telescope, you might be willing to deal with a little bit more light pollution just so you can bring awesome technology to bear, just get a great view of the night sky. Going outside to see some of this, awesome. You're so welcome, Beth. I hope you can't hear this because you're already looking up and gazing at the awesome night sky. How feasible is space travel, aka Star Trek, or a la Star Trek? Yeah. Well, the first half of the sentence, I was like, well, yeah, we've done that. A la Star Trek is a whole nother story. So the transporter beam, probably not going to work. And even if it did work, it would technically kill you and then clone you. So yes, I'm in that camp. So I'm not a huge fan of the transporter. In terms of the warp bubble, it is possible. Einstein predicted it. We've been able to model it. The most recent iteration of our attempt at a warp drive is from this guy Harold White, as the White Alcubierre, Alcubierre. So the White Alcubierre drive. And the biggest problem really is the ridiculous amount of energy that you would need to create that warp bubble and essentially create like a wave in space-time and then like surf it. There's just no way that we could get that amount of energy into a reasonable amount of space yet. So yeah, so energy costs are the biggest issue, and then the amount of energy that would then need to go into projecting exotic matter in front of the ship to create the depression in space-time. That is another issue, because just having raw energy is great, but then if you can't put it anywhere, it's useless. So we need large amounts of antimatter, large amounts of exotic matter, and a ridiculous amount of energy. But White was able to improve, I think, like tenfold on the initial work of Alcubierre. So if that just happens, 6 or 7 more times, we'll be well on our way to something like Star Trek. One of the things that always kind of amused me is that because technically a spaceship that is warping through space-time is not moving, there's no way to calculate the fuel efficiency of a warp drive, because you can't do miles per gallon if you go 0 miles in displacement, right? Somebody posted, how big is the sun? Thank you. As Einstein said, why should I memorize what I could look up? Is Mars a realistic option for colonization? Yeah, we could do it. We now know that you couldn't grow potatoes in the soil because of the perchlorates, but maybe you genetically engineer some hemp or some sort of like really tough plant, that can grow like anywhere. And I don't know, maybe some terraforming, I don't know, some extremophile bacteria or something, which of course then there's the whole ethical issue of like, well, should we really be altering an entire planet's ecosystem, even if it's just the absence of an ecosystem, even if we find out that there really is no life there? How ethical is it to alter the planet? I'm not sure that we really need to go to Mars, though, because could we? Yeah, but Mars doesn't have a magnetic field, and you could probably get water from it, but you can get water from an asteroid, and then you don't have to get off an entire planet. You're just in space with water, right? So with a couple of new manufacturing processes, when you get to the point where you can do all this stuff in 0G, you might just not need a planet, so I would imagine that at some point we're going to realize, like, oh, you can just put yourself in a giant orbital cylinder, spin it to create gravity, and you're closer to Earth, maybe even within Earth's magnetic field, like the space station is. So you're still mostly shielded from the solar wind. And then if you do need to leave the O'Neill cylinder for some reason, there's very little fuel cost associated with that, because you just kind of go outside, open the door, and jump, and all of a sudden you're in space. So I think Jeff Bezos is kind of like the self-appointed spokesperson for that point of view, that we don't really need planets. But do I? Anyway, I hope that is illuminating. Yeah, we could do it. Okay. Kitty Night Sky Festival, when the lights are turned off. Catherine, I would love to hear about the time they turned the lights off. What causes a meteor shower and what makes up a meteor shower? Okay, so this is a lot of fun. Meteor shower. Lucy, if it's all right, I'll just keep going as long as folks have questions.
I think that we still have lots and lots of people who are on and listening, and we said that you would be open to taking questions.
Yeah.
So we can remind people, if they want to go, if they're inspired to go outside right now and look at the sky, they can access the library's resources on the event page, and we'll be sending it out to attendees also. So encouraging people to borrow our telescope and to check out the many, many, many resources that the library has for people to borrow. But you're getting a lot of questions
I am.
and
I'm
and
so happy.
great ones. So yes, go for it. And we'll let
Absolutely.
people.
If it helps at all, I've set the night sky so we're looking due north here. I don't know if you can still see it on Zoom, but we're looking north, and this is the time is not set to now. So if you go outside and face north, this is basically what you should see. Okay, so what causes a meteor shower? So most of them are caused by comets. Now, comet, as you know, starts at the outside of the solar system. How far out varies a lot. There's some comets that only take like not even 100 years to go around their orbit, like Halley's comet. And then there are some that's 4,000 or 5,000 years that they take to go in a circle because they go so far out away from the sun. A comet is an icy, dusty. It's a dirty snowball basically. So as it nears the sun, solar wind and heat coming off of the sun kind of get involved with the comet, and it starts sublimating its ice. And that ice carries with it dust that was just kind of mixed in there. And so a comet has two tails. One is of dust, and that trails kind of behind it. So if you're able to image the dust tail, you can kind of see the curve of its trajectory. And then the other tail is of water ice, or vapors, I guess. And that is always pointed straight away from the sun. So when a comet is heading out of the solar system again, once it's rounded the sun and is heading back out, the tail, the more visible of the two tails, is actually in front of it because the water ice tail always points away from the sun. So that tail of dust and gas, right? You've got all these tiny little, sand-sized, grain-sized little bits of comet, right? And they kind of diffuse into a ring. So the comet isn't just that nucleus, that dirty snowball, but it's also that ring of debris around its entire orbit. And then the Earth slams into it at like 18.5 miles per second. And who knows what velocity the comet's going when it crosses Earth's orbit. And that's roughly the velocity of the dust grains. And so there is an awesome amount of kinetic energy that has to be zeroed out as the Earth just kind of like, body checks these dust grains. And so that's released as heat, of course, and it's, tremendous plasma trail through the atmosphere. And that's how you get your meteor shower. And the intensity of the meteor shower may vary from year to year based on the density of the comet's tail that you're flying through. And then the Geminids are being caused by a more metallic asteroid. And so the pieces that are coming off of it are less likely to kind of explode as they heat because they're more metallic. So there's that. A fun fact about comets, we think that the reason that Earth got so much water, because if you look at Mars and Venus and they're both totally dry, so like what's Earth doing in the middle of all this water that normally is way out at the edge of the solar system? We think that early on something dislodged like a ton of comets and sent them in towards the inner solar system, and enough of them hit Earth that we now have oceans because of all these comets that just vaporized in our atmosphere. And then so that was like how the water cycle got started. So if you ever want to see a comet, just go to the beach, and technically, there you are. Best night skies in Connecticut. Everything's like 20 minutes from Hartford, right? I don't know.
Nancy Kroll put a several links in the chat that would have some information about Connecticut
Oh,
night
perfect.
skies.
Thank you, Nancy. Yeah, there's probably an astronomy club near you too. And if you get in touch with an astronomy club, whoever you reach, they'll talk to you about where the dark skies are near you. Should we colonize Venus before Mars? Good question. So just so everyone's on the same page, Venus is an interesting case. The atmosphere at the surface is about 100 times denser than air, so it's kind of like wading through water constantly. Surface temperatures are hot enough to melt lead, and so the longest we've ever been able to get a probe to survive down there was actually the Russians. They got, I think it was like about a couple hours of footage before the lander just imploded from the pressure. So you basically need like a deep sea submarine on the surface that can also well, sulfur would melt. I mean, it's literally hotter than hell. So, and also like it rains glass, basically, or like rains shards of glass, and it's got this kind of like a jet stream, except the winds are like hypersonic. They call it an atmospheric super rotation. That the air currents that go around Venus like several times in a day. That the wind there is supersonic. So Venus is not very hospitable. But tens of kilometers above the surface, I want to say it's like 50 kilometers up or something. Don't quote me on that. I could be wrong on the exact number. But you reach this point where it's about Earth temperature. There still is no water. But if you were to build like a space station and just drop it into the atmosphere, just by having a breathable oxygen atmosphere in the space station, you'd have about 80% of the buoyancy you needed to maintain altitude on Venus. And so if you just put a couple of helium gas bags on the side of your otherwise normal kind of space station thing, you could have something kind of like Sky City out of Star Wars. And once we have missions out to the outer solar system, deliberately dislodging icy asteroids from their orbits and guiding them closer in, to harvest their water. If you develop that kind of a supply line to Venus, they'd have a steady supply of water and the protection of an atmosphere, which would protect against solar wind to some extent. And it would be the most temperate, stable place you could live, so long as you never ever go down under any circumstance. Just stay at that level that you're at, and you'll be fine. So should we go there first? Well, it's closer. It would be cheaper to get there. But whereas you could kind of view landing on Mars as not super different from landing on the moon, just kind of an extension of those technologies, landing on Venus would really require like an entirely different, solving a different set of problems. And so just for the economics of, developing all the new supply lines and all the new innovations that we need to get that ball rolling, I would guess that we're going to colonize Mars before Venus. So I can't say one way or the other whether we should, but I think eventually we will. Okay, there's Nancy's links. Oh, come on. There we go. SPL resources. How many women do you think will be a part of the 2024 moon mission? Well, boy, have I got news for you. Just yesterday, they announced that one of our own from Caribou, Jessica Meir, was selected for Artemis. So she'll be a part of that mission. And I didn't check the full NASA brief as thoroughly as I probably should have, because I was just really excited that like one of our astronauts, is going to the moon. But there was definitely like several women were selected for the class. So it's another case of like probably someone's Googling it already and can answer it before me. But ideally, representation being fair, it would be like half of the crew. Amateur clubs and viewing events in Connecticut. Yes, thank you, Nancy. Do all of those people get to go to the moon? And Artemis? It's not a guarantee. Stuff goes wrong, missions get delayed. Oh, it is. Excellent. Someone might retire or move on to something like, who knows? At any given time, I think it's a pretty slim minority of astronauts that have actually flown relative to the number of astronauts that are just in the Corps, ready to go. So I don't know. I don't know for a fact that every single one of those people announced is going to the moon. But there's not too many of them. So, a couple missions in, and at least last time I checked, they were sending crews of 6 and then 4 get into the Altair lander. So it really wouldn't be that hard to send all of them, but it'll depend on the budget and all kinds of stuff. So, no guarantees. And I wouldn't be surprised if they announced another group. But I just don't know. I'm just a volunteer. Like I'm not in at the upper levels. I wish I could say I was. That would be exciting.
Well,
Wow,
Seth, I think you got to the end of the questions that have come in. And this has been such a fun and interesting, informative program. It's been great to both have the chance to have you guide the tour of the sky on the planetarium. We can all see the Stellarium software, and it's been great to have you answering so many questions off the top of your head. So there's a lot to learn about the solar system, for sure. Thank you very, very much for presenting our program tonight.
You are so welcome. And I realize now that I didn't show you guys like the almost conjunction. So if it's okay, I want to go back to Stellarium real quick and rewind. Sure. And I'll show you. It's set by now. Let's go back. We'll find Mars and Jupiter in the early evening sky. There we go. Or sorry, did I say Mars and Jupiter? Who got me thinking about colonizing Mars? There they are. So it's in the southwest. Oh, there we go. So yeah, if you want to catch that, you would need to go out, fairly early into the evening. But yeah, okay, I'm all done.
Many, many thanks, Seth. And we will, we're recording tonight, so we'll have a recording of this for people who would like to share it with people they know. And again, we want to encourage you to borrow some of our materials, and especially the telescope, and keep exploring. Thanks for inspiring us to do that, Seth.
Always a pleasure. Thank you so much for having me. And thank you for the wonderful questions.
They're great. Take care.
Bye.
Bye.